What is the impacts of supernova? What is the shockwave? What is the supernova remnants? What is the supernova impact on Earth and life? All this answer you get in this video. What is the impacts of supernova? A supernova is a powerful and catastrophic event that occurs when a massive star reaches the end of its life cycle. During a supernova, the star undergoes a violent explosion, releasing an enormous amount of energy and radiation. These events are some of the most energetic and luminous phenomena in the universe and play a crucial role in the evolution of galaxies and the dispersal of elements. Formation of supernova. Supernovae occur when a star's core can no longer withstand the gravitational forces pulling it inward. This can happen in two main ways. Type Ia supernova. This occurs when a massive star, at least 8 times the mass of our Sun, exhausts its nuclear fuel. The core collapses, leading to a massive explosion. Type Ia supernova. This type of supernova occurs in binary star systems, where one star is a white dwarf and the other is a regular star. Material from the regular star accretes onto the white dwarf until it reaches a critical mass, triggering a nuclear explosion. Energy release. The energy release during a supernova is a breathtaking display of the universe's immense power. A supernova is a cosmic spectacle characterized by the colossal release of energy. When a massive star reaches the end of its life cycle, the gravitational forces compressing its core become insurmountable. This core collapse leads to an explosive chain reaction that unfolds within seconds. The energy released during a supernova is staggering, equivalent to the entire energy output of our Sun over billions of years, all unleashed in a matter of moments. This release of energy manifests in several ways. The gravitational potential energy of the collapsing core is converted into intense heat, causing the core to reach temperatures in the billions of degrees. Nuclear fusion reactions are reignited, resulting in an unprecedented outpouring of energy. This energy is accompanied by a flood of radiation, including X-rays and gamma rays, which illuminate the surrounding space. The shockwave generated by the collapsing core tears through the star's outer layers, initiating the explosion that we observe as a supernova. This cataclysmic event not only scatters newly formed elements into the cosmos, but also profoundly influences the evolution of galaxies and the universe at large. What is the shockwave? The shockwave in a supernova is a crucial component of the explosion. It's the forceful blast wave that results from the rapid release of energy during the core collapse and the subsequent nuclear fusion reactions within the dying star. The shockwave in a supernova is the cataclysmic shock front that emerges as the core of a massive star collapses under its own gravity and undergoes a series of intense nuclear fusion reactions. This shockwave, akin to an astronomical tsunami, rips through the star's outer layers at speeds of tens of thousands of kilometers per second, causing them to expand and disintegrate. The shockwave carries with it an enormous amount of energy and radiation, momentarily outshining entire galaxies and becoming one of the brightest objects in the observable universe. This explosive release of energy and matter not only sculpts the surrounding interstellar medium, but also plays a vital role in dispersing newly formed elements, enriching space with heavy elements critical for the formation of celestial bodies, including planets, and the diverse chemistry of life as we know it. Supernova shockwaves are the cosmic forces responsible for sculpting the vast landscapes of the universe. Element production. Element production during a supernova is a fundamental process that occurs as a result of the extreme conditions generated by the core collapse and subsequent explosion of a massive star. Supernovae are celestial crucibles for the creation of heavy elements. When a massive star reaches the end of its life cycle and undergoes a catastrophic core collapse, temperatures and pressures within the collapsing core become astoundingly high. Under these extreme conditions, nuclear fusion reactions occur at an accelerated rate, synthesizing elements beyond helium. Elements like carbon, oxygen, silicon, and iron are forged in the intense heat of the collapsing core. However, it is the final, cataclysmic explosion of the supernova that disperses these newly created elements into space, enriching the cosmos with the products of nucleosynthesis. Elements heavier than iron, such as gold, uranium, and other radioactive isotopes, are also produced during the explosive event. This dispersion of heavy elements is critical for the formation of planets, stars, and, ultimately, life in the universe. Neutron stars and black holes. The aftermath of a supernova often gives rise to some of the most enigmatic objects in the universe: neutron stars and black holes. Neutron stars and black holes are the remnants of massive stars that have undergone a supernova explosion. When a massive star's core collapses during a supernova, the fate of the remnant depends on its mass. In the case of slightly less massive stars, the core compression halts when it reaches the density of atomic nuclei, resulting in the formation of a neutron star. These incredibly dense objects, with masses greater than that of the Sun, but squeezed into a sphere only about 12 miles, 20 kilometers, in diameter, are composed almost entirely of neutrons and are held together by the force of neutron degeneracy pressure, countering the relentless pull of gravity. On the other hand, if the collapsing core is even more massive, it may overcome neutron degeneracy pressure, collapsing further to become a black hole. Black holes are regions of space-time where gravity is so intense that nothing, not even light, can escape their grasp. They are surrounded by an event horizon, an invisible boundary beyond which nothing can return. Neutron stars and black holes represent the extremes of compact objects in the universe and continue to be subjects of intense study, offering profound insights into the nature of matter, gravity, and the fabric of space and time. Cosmic impact. The cosmic impact of supernova extends far beyond the immediate explosion itself, shaping the universe's evolution and influencing the formation of celestial objects. Supernova are cosmic events with repercussions that ripple across the cosmos. Their impact reaches beyond the initial explosion, influencing the very fabric of the universe. One of the most significant contributions of supernova is the creation and dispersal of heavy elements. These explosions forge elements like carbon, oxygen, and iron during the intense conditions of a supernova's core collapse and subsequent explosion. These newly synthesized elements are expelled into space, enriching the interstellar medium with the raw materials necessary for the formation of planets, stars, and even life itself. Supernova also play a pivotal role in the life cycles of galaxies. The shockwaves and energy they release can trigger the formation of new stars, influencing the structure and dynamics of galaxies. The remnants of supernova, such as the colorful clouds of gas and dust they leave behind, continue to provide astronomers with insights into the processes that shape the universe. In essence, supernovae are cosmic engines that drive the evolution of the cosmos, leaving an indelible mark on the grand tapestry of the universe. Observable events. Supernovae are among the most captivating and observable events in the cosmos, providing astronomers with invaluable insights into the life cycles of stars and the evolution of the universe. Supernova are awe-inspiring cosmic phenomena that captivate astronomers and stargazers alike. Their observable nature makes them vital subjects of study in the field of astronomy. When a supernova occurs, it often outshines entire galaxies for a brief period, becoming one of the brightest objects in the night sky. To modern telescopes and astronomical instruments, astronomers can observe and study supernova across vast cosmic distances. These events are classified into different types based on their spectral characteristics, such as Type I and Type Ia supernova. Observing the light curves and spectra of supernova provides valuable information about their progenitor stars, the explosion mechanisms, and the formation of elements during the cataclysmic event. Moreover, the study of supernova has played a pivotal role in our understanding of the expanding universe, as these events serve as standard candles that help measure cosmic distances and study the universe's rate of expansion. In essence, supernovae are not only dazzling celestial displays, but also critical tools that illuminate the mysteries of the cosmos. What is the supernova remnants? Supernova remnants, the remnants of the explosive aftermath of a supernova, offer a fascinating window into the aftermath of these cataclysmic events and their lasting impact on the cosmos. Supernova remnants are enduring cosmic testaments to the violent death throes of massive stars. After the brilliant explosion of a supernova subsides, it leaves behind a lingering imprint on the universe in the form of these remnants. These remnants consist of expanding clouds of gas and dust, often displaying intricate and colorful structures. They continue to evolve over thousands of years, serving as dynamic laboratories for the study of astrophysical processes. Supernova remnants offer insights into the shockwave dynamics generated during the initial explosion and the subsequent interaction with the surrounding interstellar medium. As the shockwave plows through space, it heats and compresses the gas, triggering the formation of new stars and influencing the chemical composition of the interstellar medium. The remnants are rich sources of high-energy radiation, including X-rays and gamma rays, enabling scientists to explore the extremes of physics and learn more about the particles and magnetic fields in these environments. Additionally, the remnants often contain compact objects, such as neutron stars or black holes, left behind by the progenitor star, providing further avenues for research. In essence, supernova remnants are cosmic artifacts that persistently narrate the story of a star's fiery end and its lasting impact on the surrounding cosmos. Supernova impact on Earth and life? The direct impact of a supernova on Earth and life is a rare occurrence due to the vast distances between stars in our galaxy. However, it is a topic of scientific interest and speculation. While the chances of a nearby supernova directly impacting Earth are low, such an event could have significant consequences for our planet and its inhabitants. A nearby supernova, within a few dozen light years, could potentially result in increased radiation exposure on Earth. The intense burst of high-energy particles and gamma rays produced by the supernova might deplete the ozone layer, increasing the levels of harmful ultraviolet (UV) radiation reaching the surface. This, in turn, could have detrimental effects on terrestrial life, particularly for organisms that rely on the protection of the ozone layer, such as phytoplankton in the ocean. Increased UV radiation could disrupt ecosystems, damage DNA, and harm exposed organisms. Additionally, a nearby supernova might lead to an increase in the production of nitrogen oxides in the Earth's atmosphere, which could affect climate patterns and potentially contribute to ozone depletion. While such events are rare, studying the potential impact of nearby supernova on Earth and life is an important aspect of astrophysical research and planetary science. It's worth noting that there is no concrete evidence of a recent nearby supernova having a significant impact on Earth or life as we know it. Supernova within a few dozen light years are extremely rare in the Milky Way, and the last such event is estimated to have occurred millions of years ago. Scientists continue to monitor the skies for potential nearby supernova, but the likelihood of a catastrophic impact on Earth remains remote. Fortunately, Earth's atmosphere and magnetic field provide some protection against the potential effects of nearby supernova. While the depletion of the ozone layer and increased radiation levels would be a concern, the Earth's natural defenses help mitigate the impact. Additionally, life on Earth has shown remarkable adaptability and resilience over geological time scales, allowing ecosystems to recover from various environmental challenges. Beyond the immediate impact of increased radiation and potential ozone layer depletion, a nearby supernova could also have broader effects on Earth's environment. The burst of energy and cosmic rays from a supernova could ionize the Earth's atmosphere, leading to changes in atmospheric chemistry. This, in turn, might influence weather patterns and climate, potentially leading to alterations in temperature and precipitation regimes. Furthermore, the increased cosmic radiation could pose risks to both astronauts in space and airline passengers at high altitudes. It could also affect the operation of satellites and electronic systems by causing glitches or malfunctions. In the long term, the radioactive fallout from a nearby supernova could contribute to the Earth's radiological background, potentially affecting future generations. However, the extent of these effects would depend on several factors, including the distance of the supernova and the angle at which the Earth is exposed to its radiation. In conclusion, the potential impact of a nearby supernova on Earth and life is a topic of scientific interest and exploration. While the probability of a catastrophic event remains remote due to the vast distances between stars, understanding the potential consequences of such an event is essential for our broader understanding of the universe's dynamics and its interactions with our planet. A nearby supernova could lead to increased radiation, potential ozone layer depletion, alterations in atmospheric chemistry, and even long-term effects on Earth's radiological background. However, Earth's natural defenses and the adaptability of life offer some protection against these cosmic hazards. The study of supernova and their potential effects on Earth serves as a reminder of the complex interplay between celestial events and our home planet, shedding light on our place in the grand scheme of the cosmos and the remarkable resilience of life on Earth. That's all in this video. If you like the information, please hit like and subscribe to this channel, and be connected to this channel for more space information.